All right, so now let's take these out for a spin. Let's find some derivatives using the first 4 rules that we've learned. All right, so the derivative of 4 pi. Well, 4 pi is a constant. Therefore, by rule number 1, the constant rule, this should be, let's see, let me just write equals 0. Because 4 pi is constant, the derivative is 0. Right? Sorry. And I'm using rule number 1 there. Right? I'm taking the fact that I have a constant, derivative of a constant is 0. All right, now this is using rule number 3, the constant multiple rule. So if I want to take the derivative of this, well, actually, I'm going to use 2 rules at once. I'm going to be sneaky. So I'm going to use the power rule and the constant multiple rule. So the derivative of this would be, the constant says you just write the 2, and then use the power rule on this back part. So you bring the 6 down, so 6 comes right here, and then s to the 6 take away 1. All right, so I'm using actually constant rule, the constant multiple rule right here. Right, that's where the 2 comes from, right there. So that's rule number 3. But I'm also using the power rule because that's rule number 4. That's where the 6 times s to the 6 take away 1 is. Right, this part right here is rule number 4. Oh, those aren't different enough, sorry. So here, this is rule number 4. There we go. Okay, so then we can just simplify this. And honestly, you never show this step in between. Once you see how this works, you just never bother. So it becomes 12, right? 6 times 2. 6 times 2, you bring the 6 down. 6 times 2 is 12. S to the 6 take away 1, which we all know is 5. And that's what we do. We almost never show that middle step in between because this stuff kind of becomes internal to us. Okay, letter C. Well, radical signs are no good to us, so we want to rewrite that radical because we don't have a radical rule. What we have is a power rule. So I want to remember my algebra that this is telling us to take the derivative with respect to x. That's all this is telling you. Take the derivative with respect to x. It's Euler notation of x to the 1/5 power. Because we learned in algebra that a 5th power is a 5th root. All right, so then if it's a 5th power, then I can just use the power rule. And I can say, okay, well, the derivative, right, this is saying take the derivative, and then when I write equals, I'm saying this is the derivative. 1/5 x to the, well, it's 1/5 take away 1, which would be 1/5 x to the negative 4/5. And I'm okay with that being your answer. If you need to rewrite it, it would be 1/5x to the 4/5, right? Because a negative power is a fraction. Or if you like, you could write 1/5 5th root of x to the 4th. I'm actually okay with any one of those answers. They're fine. Technically, leaving a negative power is not simplified. So if you have to simplify it, you can write it like this. And if for some reason you want a radical, I don't know why, but if you would, then you would write it as this. But I'm good with any one of those 3. All right, now down here, well, similar issues. We're going to have to use a little bit of algebra because we don't have a rule for 3a in parentheses squared. Not yet. There's one coming in section 3.7, but we're not there yet. So we are going to say, all right, that's fine. Then I'm going to take the derivative with respect to x of, I'm going to rewrite this. This is 9a squared because 3 squared is 9. So now I'm going to take that derivative and I'm using rule number, well, it's number 3 and 4 again. Oh, and by the way, this one up here was just number 4, rule number 4. I only use the power rule here. But this one down here, I'm going to use rules 3 and 4 again. So number 3 and number 4. Okay, so if I'm going to take this derivative, it would be 9 in front times, right? And that's number 3 right there, leaving the 9 just sitting there, leaving the constant out. And then 2a to the 1, right? Because it's going to be 2 take away 1. So that would be 18a, and that's your derivative. This part right here is your rule number 4, right? It's your power rule. And this part right here is your constant multiple rule. Okay, now what about letter E? Well, the thing about letter E is that that t variable is in the denominator, and we don't have a denominator or a fraction rule, but we do have a power rule. So what we can do is change this. This is 2/3 times t, let me write it this way, times 1 over t, right? Because 2 times 1 is 2, and 3 times t is t, or 3t. And that would be 2/3 t to the negative 1, because a negative power makes fractions. Okay, so now notice I'm writing this d over dt every step because I'm saying take the derivative of this, take the derivative of this. I'm using algebra. I haven't actually done any calculus yet. So I'm just using algebra to rewrite it into something I can use calculus on. But now I'm actually going to do it. So I'm no longer going to write d over dt, and now I'm just going to write, well, let's see, 2/3, there's the constant, and then I bring the power down, negative 1, so times negative 1, t to the negative 1 take away 1. So that would be negative 2/3 t to the negative 2. And as with that problem for letter C, I'm okay with you leaving it like this, but I also would be okay with you rewriting it like that. Either one of those is correct, and you should be able to, with your algebra skills, go back and forth between them depending on what you need for your particular problem. Okay, last but not least, let's take the derivative of this part. So this is the take the derivative with respect to u of, and I need to rewrite this. This is negative 2 times, this is u to the negative 1/2. Okay, so having a square root is a half power. And then having it be in the denominator means it's a negative 1/2 power. We learned that in algebra class. All right, so that means that I can take the derivative, actually that's even pre-algebra, that's or rules of exponents. So when I want the derivative, I want negative 2 times negative 1/2 u to the negative 1/2 take away 1. Well, negative 2 times negative 1/2 is just 1, right? And then it's u to the negative 3/2. All right, so that's okay if you want to write u to the negative 3/2, or you could write 1 over u to the 3/2. Either one of those is totally fine. Well, unless they technically ask for simplification. Technically, the negative powers are not simplified, so if they want it simplified, they actually want the bottom version right here. So this is the simplified version. Negative powers are technically a no-no in simplification.